Okay, so I'm going to say a last thing about density matrix, and I'm going to connect it to the block sphere. So for a qubit, so a density matrix is for a density in general is a Hermitian matrix, because it needs to have real eigenvalues, not just real eigenvalues, it needs to have positive eigenvalues. Because of that, a density matrix can be expressed for the qubit as a sum of the identity matrix plus sum over the Pauli matrices. Okay, so the Pauli matrices are traceless. So because they're traceless, if you take the trace of rho, you only get one from here, and these guys don't contribute. But any density matrix in two dimensions can be expressed in this form. Okay? And these vectors bi, these numbers, they form a three-dimensional vector, b1, b2, and b3. And remember that we had a view, we had a picture in which we represented the qubit, all the pure states of a qubit, as residing on the surface of a sphere, where, in the North Pole was spin up and South Pole was spin down. Spin down. So if this North Pole, what you can show it, this is, you can show, and this is something, we are going to be exploring in the tutorial, is that you can think of it as a vector going from the center up to here. And this is, say, the vector be up, and this will be 1, 0, 0. And, the South Pole, the spin down state will be given by a vector b down, which will be -1, 0, 0. And similarly, all states, pure states, which are living on the surface of the sphere, will satisfy this condition. And then the question is, where are the mixed states? It turns out the mixed states live inside the sphere. Okay, so the mixed states are states which have, the b vector is less than 1. Okay, and the state at the center, that's a special state. It's called the maximally mixed state. This is the state where b is just, is 0. Okay. So this is this ball, which includes a sphere, is called the block sphere. So the block sphere is a misnomer because it's actually a ball. As you know, a ball is a sphere with the inside included. Okay, it's a closed ball, not an open ball. I think let's just finish here, because we have some problems that we should be discussing, and you will be exploring this in detail in the next tutorial. Okay. Okay, I'm assuming that means a yes. All right, so Let's see if I can find my solution. Okay, good.